Welcome back. In this video, we are going to solve a structural design problem that involves a cantilever beam design using LRFD method based on eStructural Design Zen found on the App Store. Design a reinforced concrete cantilever beam using load and resistance factor design with span of 2500 mm. Assume size of 200 mm by 450 mm. The beam carries a concentrated dead load of 20 kN and concentrated live load of 7 kN at edge of beam. Design criteria as follows: strength of concrete 21 MPa, main bars 16 mm bar grade 276, stirrup bars 10 mm bar grade 276. The beam carries a concentrated dead load of 20 kN and concentrated live load of 7 kN at edge of beam for a factored concentrated load of 35.2 kN. The beam self-weight is 2.16 kN per meter for a factored uniform load of 2.592 kN per meter. Enumerate input parameters required. Name of beam CB3, type of support cantilever, width of beam 200 mm, depth of beam 450 mm, length of beam 2500 mm, main bars 16 mm bar at grade 276, stirrup bars 10 mm bar at grade 276, strength of concrete 21 MPa, factored uniform load 2.592 kN per meter, and factored concentrated load 35.2 kN. Given factored uniform load equals 2.592 kN per meter, factored concentrated load equals 35.2 kN, and L equals 2.5 meters, the maximum moment from uniform load is 8.1 kN meter, and the maximum moment from concentrated load is 88 kN meter, for a total maximum design moment of 96.1 kN meter. The raw mass from given design criteria is 0.02824. Then Rn max is 6.087 MPa. And finally, the Mu max is 168.363 kN meter, greater than 96.1 kN meter, for singly reinforced beam design. Given maximum moment equals 96.1 kN meter, resistance factor equals 0.9, B equals 200 mm, and D equals 392 mm. The beam design ratio Rn equals 3.474 MPa, and reinforcement ratio Rho equals 0.01413. Given Rho equals 0.01413, B equals 200 mm, and D equals 392 mm, the area of steel for tension bars is 1107.79 square millimeters, and the number of bars for 16 mm bar is 6. The number of compression bars is 2. The shear force from dead load is 25.4 kN, and live load is 7 kN, for a factored shear force of 41.68 kN. The nominal shear force is 55.573 kN, less than 61.077 kN concrete capacity. The maximum stirrup spacing is 150 mm. The spacing of stirrups are as follows: 1 at 50 mm, 1 at 100 mm, rest at 150 mm. For 16 mm main bars, use 10 mm stiffener bars. Design recommendation as follows: Fc prime equals 21 MPa, Fy equals 276 MPa, beam size is 200 mm by 450 mm by 2500 mm. Main bars of grade 276. At support, top bars 6 pieces 16 mm bar, stiffener bars 2 pieces 10 mm bar, bottom bars 2 pieces 16 mm bar. Stirrup of 2 legs of grade 276, 10 mm bar spacing, 1 at 50 mm, 1 at 100 mm, rest at 150 mm. Thank you for watching. If you learned something from this video, please like, share, and subscribe to this channel.